Now for finding out the second part. The second part is called mantissa. It is the decimal part of log of the given number. Now it is always positive. Now how to find out the mantissa? Now for finding out the mantissa, you should be able to read the value from the log tables. Okay. So for that again, I will be showing you the log table and taking one simple example, we will understand how to read the mantissa from the log table, or how to rather find out the mantissa from the log table. So as you can see, you are again seeing a log table. So this is the standard log table, and now we'll be finding out the value of mantissa for 11. The number is 0.001184, and for that I will be finding out the mantissa. So obviously we will first find out 11 and then proceed up to 8. 1184, so 11, then reaching up to 8. So you can see the value is 0719. For 8 it is 0719, but the number is 1184, so the last digit is 4. So for 4 the corresponding value is how much? In the column of 11 we moved up to 8, and then for 4 it is 15. So 0719 plus 15. So we have to add it up, and then adding it up, this will give you how much? 0719 plus 15 will give you 0734, isn't it? So in this manner we can find out the mantissa. So as I was telling you, that if you are asked to find out log of 0.001184, then you have to consider the decimal part. The decimal part is 1184. Take the first two digits 11. We did the same thing. We moved up till there were some columns. If you remember, we moved up till the column where it was written 8, and corresponding to this value it was how much? 0.0719. And then in the last column for 4 it was written 15. So you have to add 15. So that gives you how much? You don't consider this value, you simply add 719 plus 15, so that will give you 734, and then you write down the point. So it will be 0.0734. So in this manner you can write down the value for mantissa. Now if we are able to find out the logarithm of a number, then we should also be able to find out the anti-logarithm. Anti-logarithm is nothing but the reverse process of logarithm. So anti-logarithm is to logarithm as division is to multiplication. Like for example, if log of 7 is equal to 0.8451, then anti-log of 0.8451 should be equal to how much? 7. So just like we are reading the values of logarithms from the log tables, similarly we should be able to read out the values of anti-logarithms from the concerned anti-logarithmic tables. Let me show you. This is the table for anti-logarithm. Okay. So whenever we are asked to find out the antilog of any value, like for example, you are asked to find out the antilog of say 1.3478. 1.3478. So you can see the chart, it shows 0.34. You have to only consider the values after the decimal point. I have given you the example of 1.3478. So just consider the values after the decimal point. So 0.3478. You can see 0.34. Now you have to move up till the column showing 7. So let's go up till the column of 7. So 1, 2, 0, 1, 2, 3, 4, 5, 6, 7. So in the 7th column you can see the value 2223, isn't it? But the full number is 3478. So 8 is still remaining. So what value is given in the row of 8? It is written 4. So you have to add 2223 plus 4. That gives you 2227. Understood? So in this manner you have to read the value from the anti-log chart. So very easily, if you are able to read the values, if you are able to locate the values in these tables, very easily you can do the calculations. You don't need to memorize anything. You should be simply understanding how to read the values from the log tables or the anti-log tables. If you are able to do it properly, very easily you can do some tedious calculations. Now let me just tell you the rules that you need to remember for understanding, or rather finding out the anti-log of any number. So read the anti-log of mantissa only. That is the decimal part, as I was telling you. That for 3478, 1 bar 1.3478, you have to read out the anti-log of the mantissa only. So for 3478, you have to consider 34, move up to the 7th column and consider the mean difference for 8. As I was giving you the example by showing the anti-log chart. So locating the 4 digits the way we did in reading mantissa from log tables. Now for the characteristic part, if the characteristic is positive, the decimal is placed after n plus 1 digits. If the characteristic is negative, then n minus zeros are placed before the left side. Like for example, in the first one, 1 bar, the characteristic is positive or negative? Obviously it is negative. So we have to consider n minus 1 zeros. So 1 minus 1, that is 0. Simply we have to put 0 and then the decimal point is placed. Understood? Now characteristic for the second one, see 2.7192, the characteristic is positive. So 2 is the characteristic, add 1 to it, 2 plus 1, 3. After finding out the anti-log of 7192, it turns out 5238. And then 2 plus 1, 3. See, the characteristic is 2, add 1 to it, 2 plus 1, 3. And after 3 places, 5, 2, 3, 3 places you have to put the decimal point. So in similar manner, you can very easily find out the anti-log of any number. Now let us understand the concept of logarithms, use of logarithms by solving one problem. Now suppose you are asked to solve this question. The question is, find the fifth root of 0.0076. This means you have been asked to find out 0.0076 to the power 1 by 5. Now just tell me, would it be easy to solve this question unless we are making use of logarithms? Like using any simple technique, can anybody tell me how to find out the fifth root of any number? You might have studied about finding square roots, cube roots in your junior classes, and there are so many methods for finding out square roots, even for decimal numbers. But finding out the fourth root, fifth root, this is just not possible. So just see how we can very easily find out the fifth root using log tables. So that's why I'm showing the log table side by side, so that it becomes a bit convenient to solve it very quickly. Okay, so now if x is equal to 0.0076 raised to the power 1 by 5, we will be taking log on both sides. So taking log on both sides, we get log of x equal to log of 0.0076 raised to the power 1 by 5. Now if you remember log of m to the power n, that rule, power rule, obviously the power comes as a product. So in the next step I will be writing down log of x equal to, the power will come in front, so power is 1 by 5, log of 0.0076. So just see, the power 1 by 5 has come in front. Okay, now in the next step we will be writing down the log of 0.0076. Now 0.0076, this is a number less than 1. So if the number is less than 1, so obviously first of all you have to find out the characteristic and then proceed with the mantissa. So if the number is less than 1, what should we do? Do you remember the rule for finding out the characteristic? If the given number is less than 1, its characteristic should be negative and it should be put under the bar. So we have to count the number of zeros immediately after the decimal point. So how many zeros are there after the decimal point? There are 2 zeros. So now add 1 to this number. So 2 plus 1 will give you how much? 3. So now I will be writing down 3 and then putting a bar sign. Okay, putting a bar sign. Now put the decimal point, and now we have to find out the mantissa, that is for the decimal number. So consider 0076. 0076. So the number is 76. Okay, 76. So you can see the log tables. Let me proceed to 76. See, this is 76. Can you see? And what is the number? 8808, isn't it? For 76, the number is 8808. See, we don't need to move up till any other column. The number is 0076, so the number ends at 76. So we don't need to proceed to any other column. We will confine ourselves to the first column only. So for 76, it is 8808. So 3.8808. See, I am simply noting down the values by looking into the log table. Okay. Now, this may be written as 1 by 5 Can't we write this? Can we write this? Read 3 bar as minus 3. So instead of writing minus 3, I have written minus 5 plus 2.8808. Okay. Now solve this out. On solving this, you will get log of x equal to 1.5762. 1 bar 0.5762. Now you have to take the anti-log of both the sides. That will give you the value of x. So how to take the anti-log? 5762, 0.5762. So see, 0.57. This is 0.57. You have to go up till 6. So 0, 1, 2, 3, 4, 5, 6. So in the sixth column it is written 3767. 3767. But again there is a 2 in the end. So after 3767, for 2, the value is 2. So you have to add 3767 plus 2. So that gives you 3769. So you get antilog as 3769 for this part, but we have to take care of 1 bar also. So since the number is negative, so you have to put how many zeros? 1 minus 1 zeros. So you have to put 1 0 and then put a decimal point. So the fifth root of 0.0076 is 0.3769. Okay. So now there is a task for you. You will be finding out this one and then try to solve this one. Okay, you will be solving these two questions, the first one being this one and the second one being this one. Try to solve it using the log tables. Thank you.